Hello beautiful people and welcome. In today's video we are going to go through the Integrated Math 1 Chapter 5 practice exam. Now this exam is going to be similar to the one that you are going to see in class. Let's go ahead and get started. First question is asking you to solve the system using the elimination method. Any other method will receive 0 credit. So for this is a level 1 question. We are looking for the opposite symbol. We are looking for the same number and the same letter combination. And we're looking between two equations. So for us, we see this 5x and this negative 5x. These are opposites. One's positive, one's negative. Both are 5 and both are x's. When you have opposites and the same number letter combo, we are going to add vertically, so that means up and down. And I'm going to put little separators here just to show you what we're doing. So we have 5x plus a negative 5x. Here we have a negative 4y plus a 6y. And I'm writing small here to fit in to this little section here that I've created. 23 plus a negative 17. Now 5 plus a negative 5, this is 0 x's. Negative 4 plus 6, that is a positive 2y. And we have it equals 23 and a negative 17. That is a positive 6. Now we're not done. We're going to drop this 0 because we don't have any x's. We don't need to write that. We have 2 times y is equal to 6. We're going to then divide by 2 both sides. We have y is equal to a positive 3. Now I'm going to put that in a thinking bubble because this is not the answer. For the answer, we need both an x and a y value. So we're going to choose one of the equations. It doesn't matter. I chose the top one. I have 5x minus 4y is equal to 23. I'm going to then open up y. Now the reason I'm opening up y and not x is because that is the value I have solved for. I have a y here, so I'm going to replace y with 3. Now moving forward, I am going to then type this into the calculator or evaluate this. Make sure you take care of that negative. So negative 4 times 3 is a negative 12. And now we are back at solving equations. Here's my dotted line. I'm going to add 12 to both sides. Bring down the 5 times x. Here we have 23 plus 12. That is a 5. That is a 3. We're going to then divide by 5 both sides. We have x is equal to 35 divided by 5 is 7. And once again, I'm going to put that in a thinking bubble because that is not our answer. So our answer is the combination of both the x and the y. When you write your answer, you want this in an x, comma, y format. Our x is 7, comma, our y is 3, and this is our answer. Moving forward to question number 2. Question number 2 is asking us to solve the system using substitution. This is a level 2 question because both are not equal to y. We have one of them equal to y, the other one is not. Any other method will receive 0 credit, so make sure you are using substitution. Now this one we're going to rewrite the equation that is not y equals, and we are going to open up a big parentheses where we have the y. Now instead of writing y, we're going to write what y is equal to. So we're going to pick up all of this and we're going to write that inside of parentheses. So I have a 2 negative x plus 3. Now what makes this a level 2 question is that we are going to need to distribute this negative 8. To distribute, we're going to multiply inside of the parentheses, bringing that negative 8, make sure you take the negative with you, onto that negative 2 and onto that 3. Remember, we are multiplying. This is all times. So we still have that negative 5x out in front. Now negative times a negative is a positive, so we're going to have a positive. 8 times 2 is 16x. Negative 8 times a positive is negative. 8 times 3 is 24. And now we still have that equals to a negative 2 on the other side. Here we are going to need to combine two combined-like terms. So you have 16x minus 5x. That gives us an 11x. Bring down the negative 24. And we are going to add 24 to both sides. Bring down the 11x. This is 11 times x. Here's our dotted line. And we got 24 minus 2, which is 22. We're then going to divide by 11, both sides. So x is equal to 22 divided by 11 is 2. Once again, that belongs in a thinking bubble because that is not our answer. We have to then go back to what we are given, and I'm going to choose this y equals equation one more time, but this time I'm going to take the y equals as well. So y equals negative 2x plus 3. Now I'm going to open up for x. And the reason I'm opening up for x, because that is what we solved for. We're going to place the x inside, which was 2. And either you can type this into the calculator or you can do this by hand. We got negative 2 times 2, which is a negative 4. Negative 4 plus 3 should be a negative 1. Again, thinking bubble because that is not our answer. Our answer is the combination of the x and the y. So I'm going to take the x, I'm going to take the y, and once again make sure that you're writing this in the correct format. X goes first, then goes y with a comma and parentheses. So we got 2 comma negative 1 as our answer. Okay, moving forward, we got question number 3. Question number 3 is saying solve the systems by graphing. Any other method will receive 0 credit. This one is already provided to you in slope-intercept form. So we're just going to graph this. Remember, this is our intercept, our y-intercept. Make sure you take the symbol with it. And here's our slope. We have a slope of negative 1/2 here. So we're going to go down 1 and to the right 2. Because this is an equals and equation, there are no shading or there's nothing to color in. This is just going to be us seeing where the intersection is between these two lines. So we start at 1, we go down 1 over 2, down 1 over 2. Now something that I have been seeing, you guys are sometimes not giving me enough points. Now I understand it takes only 2 points to form a line, but because we're trying to find the intersection, you have to give me as many points as possible here. So don't stop after 2-3 points. Go ahead and make sure to mark it all the way. Now you're going to pick up a ruler. I am not going to grade anything without a ruler. Sometimes the squiggly lines get a little interesting. This is an equation. Equation lines are going to be solid. We're not dashing or dotting this line. Now this is a system, so we got to do it once again, but now we're looking at the second equation. We have our y-intercept at 0, negative 1 this time. We do have the same slope at negative 1/2, which means once again we're going to go down 1 and to the right 2. So we're starting at negative 1 this time, down 1 to the right 2, 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 and again we continue. I know it gets a little repetitive, that's kind of the point. Once again, as many points as possible, and we are going to do a solid line because this is an equation. Now the question to this system is solve. The answer, we want the answer. The answer to a system is where do they intersect? Where do they cross? Now you can obviously see that they're not crossing, they're kind of parallel. So these are two parallel lines. So because they are parallel lines, there is no crossing. They don't touch. They will never touch. And because they never touch, our answer is going to be no solution. And again, it's because the lines do not cross. Our answer is no solution. Okay. Moving on to the next one. This one is also asking you to solve the linear equations by graphing. This one is a different setup, but it's exactly the same thing, I promise you. The difference is they're putting an equals in the middle. What we want to do is we want to take the left side and rewrite that as an equation equal to y. I'm going to focus on that left-hand side first. So that means we have a slope of 1/3 positive. That means we're going to go up and to the right. And that means that we have a, ooh, that was weird. All right, and then that means we have a y-intercept at 0, -2. Let's go ahead and graph that. I'll color code that in blue. So we have a -2. And from -2, we are going to go up 1 and to the right 3. 1, 2, 3. Up 1, 1, 2, 3. 1, 1, 2, 3. And again, do it on the other side. You always want to start going to the right and then follow the pattern. Once again, this is an equation, equals. So we're going to have a solid line. The trick is with the ruler, place it a little bit above or below your points and then have your marker or your pencil be the one that's on your points. All right, so we have one done, and now we're going to do exactly the same thing for the other one. I'm going to circle that right-hand side, and I'm going to create an equation, setting that equal to y. And so here we have our y-intercept, and we have our slope. And our slope is -2 over 3. So we're going to go 2 down, 3 to the right. So starting at +1, 2 down, 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And again, the opposite way. 1, 2, 1, 2, 3. Okay, and again, this is an equation, so we're going to have a solid line. Connect. Now, we can see the difference between question number 3, where they will not ever touch and they don't touch, versus question number 4, where you can see the clear intersection between the two lines. So our answer is this intersection. Now, to get the answer, you're going to find your x value, then you're going to find your y value. So where on the x and where on the y? So on the x, that number is 0, 1, 2, 3. And where on the y? 0, -1. This is our answer to the system. All right, let's go ahead and move on. Question number 5 is asking us, tell whether the ordered pair is a solution. Now this is now an inequality. This is not an equals, it's a greater than or equals. To test if something is a solution or not, you're going to label your point x and y. You're going to open up for x, you're going to open up for y. Copy down everything else. You're going to put in your x and your y symbols. These are numbers. Your x and y numbers. That was weird. And you're going to type this into the calculator. Now again, you can do this by hand. I do encourage you to use a calculator though, because all you got to do is type this in and press enter once. So we have a -3, open, 6, close, minus. Now make sure you're using this minus here on the right hand side, not a negative. 4, open, negatives down at the bottom, 3, close it. So we have a -6. So we're going to bring down -6, bring down our greater than or equal to, and 6. So this is asking, is -6 greater than 6? Or is -6 equal to -6? Now this is a false statement, But I'm going to show you on a number line, if you're ever stuck, the right-hand side's bigger, the left-hand side's smaller. So you're going to write in your 1, 2, 3, 4, 5, 6. 6 is bigger. 1, 2, 3, 4, 5, -6. Here are the two numbers that we are comparing. We are comparing -6 to 6. -6 is smaller because it's closer to the left. 6 is bigger because it's closer to the right. This is false. Now, I'm going to put this in a thinking bubble because false is not your answer. False is the inequality. Is the inequality true or false? It's false. So the answer is this point a solution? So no, 6, -3 is not a solution. This is your answer. Saying something true or false just is talking about the inequality. We want the inequality here, not this one, this one. All right, moving forward, question number 6. For question number 6, we have tell whether the ordered pair is a solution. So similar question, but if you notice, I'm not giving you one inequality, I'm giving you two inequalities. When you have two inequalities, you're going to create a t-chart and you're going to write each inequality on one side. So we got 2x minus 3y is greater or equal to 3, and the other one, x plus 3y is less than 6. You're going to label your point x and y, and just like we did on the other side, you're going to open up for x, you're going to open up for y. So open x, open y, open x, open y. You're going to put in your x, which is 0, put in your y, which is 3. X is 0, y is 3. And again, just like we did on the other side, this is going to be typed into the calculator. These two are going to be brought down. This is going to be typed into the calculator. These two are going to be brought down. Now, you don't have to use a calculator. You can absolutely do this by hand. 2 times 0 is 0. -3 times 3 is a -9. 0 plus 3 times 3, so 0 is gone. 3 times 3 positive is a +9. So let's ask ourselves, is this a true or a false statement? Is -9 bigger, greater than 3, or is it equal to 3? And both of those are false. -9 is not bigger than 3. 9 is smaller than 6. Well, no, 9 is not smaller than 6, so both of these are false. Again, true or false, that is not the answer. What we want to know is this point of 0, 3 a solution to the system of inequalities? So because both of them are false, we have no, 0, 3 is not a solution. The only time you will say yes, it is a solution, is if both are true. So you have to have true, true, yes. True, false, false, true, no. Okay? Both false, one of them false, the answer is still no. We need both true. Moving on towards inequality, this is now graphing inequalities. This is where we're going to be shading in. You're going to start with looking at how many variables you have. There's one variable or there's two variables. One variable is when you see one letter. Since we're talking about x, we're going to be taking a look at the x-axis. Then we're going to ask ourselves, is this going to be a solid or a dotted line? Dotted or dashed? I say dotted. So because we have this or equals to, this is going to be solid. So we're going to find 2 on the x-axis. Here's 2 on the x-axis. And I'm going to draw a solid line going through 2. Now when you graph this, you want to make sure to go past the given graph, the little picture, so that way I can see where your line is. Now this is not done because it says make sure to shade in the true region. So we're going to get a test point. Now it doesn't matter where your test point is. This is 0, 0. I usually like to go 0, 0 if possible. Here's your test point. So our test point of 0, 0. I'm going to label as x and y. And just like we did in 6 and 5, we're going to open up the x value. We're going to put in our x, and we're going to ask ourselves, is this a true or a false statement? Is 0 less than or equal to 2? This is true. 0 is smaller than 2. So because this is true, we're going to make sure to shade in the true region. That means everything on this side is going to be true. Now when you're shading this in, be careful not to go past that line, because anything on the other side is going to be false. So I'm going to turn my page here just for a little bit. So we have our shaded true region. So any point on this side, if we plug it in, it will give us a false statement. Moving on to the next one, same thing. Notice that, or look and notice that we have a different letter. We have a Y. So because we have a Y, we're going to be looking on the Y axis. Is this going to be solid or dotted? I see that line again, so this is solid. And we're looking for a -7. So here's our y-axis, 0. Here's -5, 6, 7. Here's -7. And I'm going to be graphing the line solid. So go just a little bit below it, so that way your marker or your pencil can be on -7. Now again, we need a testing point. I like to choose 0, 0, so here's my testing point. Once again, I'm going to copy this down. Oh, let's write out what our testing point, I forgot. Test point is 0, 0. Open up for y, label your point x and y, and then put in the y value. So 0 is greater or equal to -7. Now sometimes this can be confusing with the zeros. So here's 0, here's our bigger side, here's our smaller side, and here's -7. So you can see that -7 is closer to the smaller towards the left-hand side, and 0 is on the right. So that means -7 is smaller, 0 is bigger. So let's read this together. This says 0 is greater than -7. Is that true or is that false? 0 is bigger than -7. 0 is bigger, -7 is smaller. So this is a true statement. So because it is a true, everything in this section above the line is going to be true. Let me get a different color so it doesn't blend in. Again, do not go past that line. Past that line is going to be a no-no. So that means everything in that section is true, but everything below it would give us false statements. All right, let's move on. That was question number 7. Question number 8. Question number 8 is a two-parter. So you have A, you have B, even though you have ABCs. So you have 1 and 2. Graph the following linear inequalities with 2 variables. Make sure to shade in the true region. So let's start with the one on the left. This is already given to us in slope-intercept form. So it's asking us, is this line dotted or solid? So we're going to take a look at this symbol. And because this symbol does not have the or equals to that little line underneath, this is going to be dotted. You can also say dashed. Next, it's asking us for the slope of the line. What is the slope? The slope is the number in front of x. So we are taking 1/3. Now, do not put x here. X is a variable. It's a letter. It's not slope. We just want the numbers. Now, it is your choice if you want to already say up and to the right. I'm okay with that because we do have a positive 1/3. Next, it's asking us what is the y-intercept. Now, the y-intercept is going to be with the symbol, your number at the end. Now, this is not just taking the number and copying it down like we did for slope. This is a point, so we have to write it as a point. So 0, comma, positive 3 is our y-intercept. We want to write it as a point. Let's go ahead and graph that inequality. Let's start off with our y-intercept at 3. Let me change a color. Positive 3, 1, 2, 3, and now we're going up 1 to the right 3. Up 1 to the right 3. Again, you want as many points as you can, so we're not guesstimating. Now again, be careful here. Is this line dotted or solid? We wrote dotted, so we're going to put this a little bit underneath our points and then draw the dotted line, or dashed. Technically, we're doing dashed. Again, go a little past so I can see it, since you'll be writing in pencil on the exam. Now we're not done. Because this is an inequality, we want to make sure to shade in the true region. That means we're going to be needing a testing point. Again, I like to choose 0, 0 as a testing point. So I'm going to go here and say testing point. And my testing point is 0, 0. Now I'm going to label that x and y, and I'm going to copy down the original inequality. Y is less than 1/3 x plus 3. Now when you do this, you have to put 1/3 in parentheses, and when you open up x and y, you still want that 1/3 in parentheses, especially if you're typing that into a calculator. Our x value was 0, our y value was 0. This is what you're going to type into the calculator and see what that calculator gives you. Bring down these two, and we have 0 times 1/3, which makes that go away. We have a 3 left over. Let's read that and see if that is a true or a false statement. And we have 0 is less than 3. Is 0 smaller than 3? Yeah, 0 is smaller than 3. This is true. So because this is true, everything in this section right here is going to be shaded in, because we are shading in the true region. Make sure you do not go past that line, because above this true section is our false section. So everything here ends up being false. Okay, moving on to 8b. This one is saying solve for y, box your equation. So notice that the equation, that's a typo. Shame on me. That's not an equation. Inequality. 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 That was weird. All right, so let's go ahead and solve for y. We are going to copy down our inequality, not the equation, inequality. We're going to then solve for y by subtracting 5x. Here's my dotted line. Now when you're subtracting or adding here, you're just copying things down next to each other. You're not actually combining like terms. None of these are going to be like terms. You do need to divide by 3 for every single thing that you see. I think that rhymed. So we have y is, I'm going to leave the inequality sign for a second. We have negative 5/3 x. Negative 9 divided by 3 is 3. Now the reason I paused or I hesitated is because I wanted to check if this was negative. So we have a 3, we are dividing by 3. We want to make sure that if it is negative, which it's not negative. If it is negative, you have to flip the inequality. Since it is not negative, we're going to keep the inequality exactly the way that it is. So we're going to copy this down, bring it down. I'm going to put this in a thinking bubble so I don't lose it, because that is the answer for A. So now we're going to answer B, C, D based off of our new inequality. Is this line solid or dotted? Okay, well this is a less than without the equals sign, so without the or equals, it's going to be dotted. Then we have our slope. Our slope is going to be the fraction or number, it doesn't have to be a fraction, in front of x, which is a negative 5/3. And okay, I'm okay if you write down and write. And we have our y-intercept. Y-intercept is going to be the number in the back. Make sure you take the symbol with it. So if it's positive, take the positive. If it's negative, take the negative. And you also need to make sure to write it as a point. It's not just -3. It's 0, -3. So when we have this 0, -3, let's find -3, -1, 2, 3. We're going to put a point there. And we're going to go 5 down and 3 to the right. 1, 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. Again, 1, 2, 3, 4, 5, 1, 2, 3. This is going to be a dotted line. So I'm going to put it a little bit underneath it and draw my dash. Make sure it's very easy for me to see whether it's solid or dotted by extending it past what is given to you. Oop, didn't mean to hit the screen. All right. Again, we're not done. This is an inequality, so we have to do a testing point. Again, I choose to do a testing point of 0, 0. For me, it's the easiest. So we're going to be testing this section right here. So our testing point is 0, 0. Same thing like we did before. We're going to label the x, then label the y. Copy down the original. Open up for x, open up for y. And here's an example of why I choose 0, 0 as my testing point. Because if I have a 0 for x and 0 for y, 5 times 0 is 0. 3 times 0 is 0. So 0 plus 0 is 0. So is 0 smaller than -9? Here's that one time where we might need to do a number line. Here's 0, here's our bigger side, here's our smaller side, here's -9. So we can see that -9 is smaller, 0 is bigger. So is 0 smaller than -9? No, that's not true, that's false. So that means that all of this section is false. That's false. So everything underneath it, that is your true section. Okay. Now moving forward to our last question, question number 9, I'm going to keep this with me because if you take a look at what this says literally, take a look at your colored answers from number 8. So here are my colored answers from number 8, my shaded in regions. Now, graph the same inequalities as a system of inequalities. Make sure to shade only the true section for the system. I gave you a hint. It says identify the colored with both colors. So we're going to graph exactly this and this on one axis. So I'm going to start with the blue. So I'm going to graph this exact thing. So I'm going to put this on the side so it's not bothering me. We're going to start with that 3, positive 3. We're going to go up 1 to the right 3, up 1 to the right 3, up 1 to the right 3, and continue the pattern. We said this was going to be a dotted line. Again, make sure to go past what is given. Make sure you have arrows. And I'm not going to color in just yet. Okay? Then I'm going to graph the second equation that was in green. And we're going to start at -3. 1, 2, 1, 2, 3. And I'm going to go down 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. Now, there is an intersection between these two lines. We really don't care about that. This was dotted. We don't care about that because this is a system of inequalities. So that means we are not looking for a point as an answer. We're looking for a colored region. So again, Make sure to shade only the true region for the system. Identify the colored in section with both colors. So let's take a look. If I was to color this, I would be coloring everything underneath. Do you see how this is underneath? Underneath. Underneath. Then I would be coloring underneath here. So if I do this with my fingers, these two sections and these two sections, notice that I am touching this section twice. These two sections and these two sections. This section ends up getting double colored. So it ends up being with the peachy color that I did and the purple color that I did. So this one would be for the blue line. This is for 8A. And this one would be for 8B. And so the answer is this shaded in region, nothing else. All right, beautiful people, that is it for your practice test. Good luck, and make sure that you are ready for your test. Thank you so much for watching. Bye.